Welcome back. Now we will have a short lesson on Wheatstone bridge circuits. Wheatstone's bridge. Now, the Wheatstone's bridge circuit consists of 5 resistors, 4 of them connected along the sides of a square or a rectangle, and there is a 5th resistor connected across one of the diagonals, and you apply the power across the other 2 diagonal points. Here we apply the power. Let us assume that the current flows in this direction. Here, take it as I. Let's call this resistor R1, this R2, R3, R4, and a diagonal resistor R5. The current through R1, let us take it as I1, and here through R2 you may take it as I2, and through R3 the current is I3, and through R4 you have I4, and through the diagonal resistor let the current be I5. So this is the Wheatstone bridge circuit. Now, this circuit is said to be balanced if the current through the diagonal resistance is 0. So when balanced, I5 is equal to 0. There won't be any current through the diagonal diagonal resistor. Let us mark all these points with letters so it's easy for us to explain how does it happen. A, B, C and D. Well, there is no current from B to C along the diagonal. It means both B and C are at the same potential. So you can say this implies B and C are at the same potential. That means the potential drop across R1 and across R2 must be the same. So we can say, therefore, potential drop PD across AB is equal to PD across AC. So you can just write this as, what is the PD across AB? This is I1R1. I1R1 is equal to I2R2. Put as equation number 1. The same way, the potential drop across R3 must be the same as potential drop across R4. So you can just write potential drop across BD, potential drop across BD is equal to, what is this in here? CD, potential drop across CD. So what is the potential drop across BD? What is I3R3? I3R3 is equal to I4R4. I4 R4. So that is equation number 2. Now we apply the Kirchhoff's first rule on the junctions, or at the junctions B and C. You can see that since I5 is equal to 0, since I5 is equal to 0, we can say I1 is equal to I3. I1 is equal to I3, and we can say I2 is equal to I4. I2 is equal to I4. So these two equations together, let us call equation 3. Now, what you can do here, in equation number 2, instead of I3, you may write I1, and instead of I4, you may write I2. So, substitute equations 3 in equation 2. You would get, instead of I3, you should write I1. So you get I1 R3 is equal to, instead of I4, you may write I2. So I2 R4. Put it as equation number 4. Now, if you divide equation number 1 with equation number 4, so equation 1 divided by equation 4, you would get, in both the equations, you have I1 and I1, so you can just write these I1, you can write I1 R1, I1 R1 R4, I1 R3 is equal to I2 R2 R4, what you may get here, I2 R4, I2 R4. So I1 get cancelled, I2 get cancelled over, you will get R1 R4 R3 is equal to R2 R4 R4. So this is the condition, the balancing condition for Wheatstone's circuit. You can actually interchange these two things. So you can write R1, you can also write the same thing. If you take R2 to this side and R3 to the other side, you may write the same thing. The same thing implies you can write R1 R4 R2 is equal to R3 R4 R4 R3 R4 R4. This is also the same, the balancing condition. Now, suppose in the balanced state, you will not have R5 anymore here, because there won't be any current. You can remove the R5. So, when balanced, R5 can be removed without affecting the circuit. You may be able to remove R5 because there is no current through R5, the balanced state. Then what we have left with R1, R2 and R3 and R4. R1 and R2. Now look at here. When you look at this circuit, you can see that R1 and R3 are series and R2 and R4 are series. So the effective resistance will be, you can say, this branch and this branch. Now this equivalent circuit looks like this. What is this resistor? This is R1, and here we have R3. This is R1, this is R3, and here we have R2, and here we have R4. So you can see that, and the power is connected across these lines. So the effective resistance will be, this is R2. R2 plus R4 and R1 plus R3 are the series. So you can write the effective resistance of this circuit or effective is equals to this and this are parallel. So how can you say that? You can write R1 plus R3, R1 plus R3 times R2 plus R4, R2 plus R4 upon R1 plus R2 plus R3 plus R4. So this is the effective resistance of a balanced Wheatstone bridge circuit. So there are two important things you have to remember. Let's take this as equation 5, equation 6, and here we have equation 7. So the equations 5, 6 and 7 tells you the conclusions. These two 5 and 6 equations 5 and 6 will give you the balancing condition for a Wheatstone bridge circuit, and equation 7, that is R1 plus R3 times R2 plus R4 upon R1 plus R2 plus R3 plus R4. This gives you the effective resistance of a balanced Wheatstone bridge circuit. Thank you for being with me during this lesson. Thank you very much.